Hello everyone! In this short tutorial, we will see how to provide a random value for the intensity of a light source in Blender. Specifically, we will discuss using the Noise Modifier on animation curves. This modifier can be used with all animation curves present in Blender, so its use is not limited to light sources, but it can involve colors, movements, rotations, and generally anything that can be animated in Blender. This tutorial was created with Blender 3.3, but the concepts and tools discussed here are valid from many previous versions of the software. Before we go on, I remind you that, as it happens with most of my tutorials, the text version of this video tutorial is available for free download from the link provided in the description. I imported the model into an empty Blender scene, where I then inserted a plane on which to place the lamp. This will make the rendering more interesting, as we will see the light projected onto the surface of the plane. I insert a point light source inside the glass container, setting the intensity of the light source to 1 watt to do a test. As seen in the video tutorial about the cycles modifier for animations, I need to check the radius value of the newly created point light source, which is actually too large for the kerosene lamp object, so the resulting lighting is not correct. I therefore reduce the value of radius until the circle representing the physical size of the light source fits inside the glass container. To analyze the effect achieved up to this point, I switch to Rendered Display mode in the 3D viewport. I'm setting 200 samples and turning on denoise for the render preview, to be able to evaluate the effect more quickly. To make the effect more noticeable, I set the intensity of the world background lighting to 0. In my 3D model, the glass is completely transparent, as if it was brand new. To make it more frosted, I disconnected the texture associated with the roughness channel of the material and manually set a light gray for this channel. I analyze the result in real-time in the 3D viewport in rendered mode, until I reach an acceptable result. Okay, the initial setup of the sample scene is complete. Let's move on to the flickering effect. I open a graph editor window with the point light source selected. To be able to provide a modifier to the curve of the power parameter of the point light object, I must first create an animation curve for this parameter. This can be done simply by inserting an animation keyframe for this parameter, for example at the first frame of the timeline. Before inserting the keyframe, I set the value of the power field to 0. This will make the rendering completely black, but trust me, the reason will become very clear as soon as we add the noise modifier to this parameter. To insert the keyframe, I place the mouse cursor over the power parameter and press the I key. Alternatively, I can right-click on the power value and select Insert Keyframe from the menu that will appear on the screen. Now I have the power curve available in the graph editor window. In case the keyframe is not easily identifiable, place the mouse cursor in the window, press the A key and then the period key on the numpad. This will have the effect of framing the keyframe, selected with A as it is the only element present in the window. I insert a noise modifier from the side panel of the graph editor window. This panel can be opened or closed with the N key. The first parameter of the newly created noise modifier is blend type, and it is very important to know the options it provides, because it will be possible to modify the value of the parameter in a very different way depending on the mode selected. The second fundamental parameter of this modifier is strength, which allows defining to what extent to modify the starting value. The value of strength can also be negative. The names of the modes easily suggest how the value of the parameter to be modified will be altered. Add will add a random value in the range between 0 and strength, so we will be sure that the final value will never fall below the value we set in the first keyframe, unless we set a negative value for strength. Subtract will, of course, perform a subtraction between the values. In our case, it would be useless because the initial value is 0, so any value resulting from the subtraction would be negative, and the point light object will not emit light. Multiply will multiply the original value by a value between 0 and strength. This could lead to much more extreme variations than those given by the add mode, if the original value of the parameter to be modified is different from 0. In our case, power has an initial value of 0, so multiply will have no effect, because any value will be multiplied by 0. Replace will completely replace the starting value with the one given by strength, but be careful when using this parameter, because strength represents the amplitude of the disturbance, so it might also make the parameter to be modified take on negative values. For this value, we will use the add mode. In particular, to create the animation you are seeing on the screen right now, I set 30,000 as the value of the strength parameter, so the luminous power of the light source actually varies between 0 and 3 watts. Another very interesting parameter of the noise modifier is scale, which allows you to make the flicker more or less frequent. With a value between 0 and 1, we will have sudden changes between values, while for values much greater than 1, we will have very smooth interpolations extended over time. For the rendering I showed you earlier, I used the value 1 for this parameter. The Restrict Frame Range section is also very interesting, allowing you to specify the range of frames in which to apply the effect. This can be useful for inserting a flickering effect at certain moments during an animation. For example, for a light source that suggests that the lighting might fail at any moment, in a scene full of tension. As I told you at the beginning of the video tutorial, the noise modifier can be applied to any parameter that can be animated in Blender. So, I am doing a test with the radius field of the point light source, but this time with a different mode for the noise modifier. First, I go back to the first keyframe of the timeline and insert a keyframe for the radius field of the point light source, with an initial value of 1. In the graph editor window, I select the new animation curve, called Shadow Soft Sides. To easily locate the Shadow Soft Sides keyframe, I can disable power, select all with A, and press the period key on the numpad. As you can see, this time the value on the vertical axis looks more like the one in the radius field, unlike what we saw with power. I then insert a noise modifier to this curve, this time changing the mode to Replace. I now set scale to 0.5 to have more frequent and sudden variations. Finally, I set strength to 1.9. This is, in a sense, the maximum value for this particular animation, because the starting value of radius was 1, and strength represents the maximum amplitude of the noise, which needs to be divided by 2 to understand how much it could increase or decrease. Since radius has a value of 1, if I set the value of 2 for strength, I could get a final value between 2 and 0, which we want to avoid. By setting 1.9, I will get very low random values for this parameter, but without the risk of reaching 0 or even negative values. Before starting the new rendering, I also set the value of the scale parameter of power to 0.5, so as to have more sudden variations for the intensity of the light source, as well as for its radius. On screen, I am showing the final animation obtained using the noise modifier on both the power parameter and the radius parameter, with the modes that I described earlier. Well, that's all for this tutorial. I hope it has been helpful. See you soon!